multiplying fractions by a whole number, as well as adding and subtracting mixed numbers, came up a lot on your packet. For example, 2 times 1/3, or 1/3 times 2, 8 times 3/5, or 3/5 times 8. And as I said, adding and subtracting mixed numbers. Such as 4 1/8 plus 6 3/4, or 12 1/2 minus 5 1/3. Let's get started, kids. So for 2 times 1/3, or for any fraction times a whole number, there are two options. You could first think of it as two groups of 1/3. In order to do it that way, you would need to draw a bar model, shade in 1/3 in each model, and then simply count how many 1/3 there are, 2/3. Or if you wanted to convert 2 into its fraction form, 2/1, you would simply multiply across the numerator and denominator. For our second example, 3/5 times 8, you could do it the same way. You can think of it as 8 groups of 3/5. You would draw your 8 bar models or Snicker bars, and you would divvy them up into 5 equal parts. After I draw my 5 equal parts, I would need to shade in 3/5 in each model. After shading my 3/5, I would simply skip count to figure out how many fifths in all. And in all, that would be 24/5. That's an improper fraction. We could rewrite it as a mixed number. It would be 4 4/5. 4 wholes and 4/5 left over. The second way to do it would be to simply make 8, the whole number, into its fraction counterpart, which is 8/1, and then we would multiply across the numerators, giving us 3 times 8 is 24, and 5 times 1 is 5. Okay, so now for the second concept I wanted to touch on, which is adding and subtracting mixed numbers. I'm going to show you the long way, but you might find that eventually, with additional practice, part of this can be done mentally. So our first example, 4 1/8 plus 6 3/4. The first thing you do is you rewrite it vertically, lining up your whole numbers and your fractions. You'll notice that the fractions have different denominators. So we need to use least common multiple to figure out what equivalent fraction to 1/8 and 3/4 I can use to more easily add them. So to the side, I write my denominators, my 8 and my 4. Then I list the next 4 multiples after the number itself. So for 8, it's 8, 16, 24, 32, and 40. And for 4, it's 4, 8, 12, 16, 20, and 24. The least common multiple is the number they have in common and appears on both lists, and in this case is the number 8. Luckily, I only have to change my 3/4 to 8ths to be able to work out my addition equation. So what I then do is I work out what I multiply my 4 by to get 8, which is 2, and I do the exact same to my numerator. Because 4 times 2 makes 8, I multiply my 3 times 2 to make 6, and then I go ahead and add 1/8 and 6/8. And my answer is 10 and 7/8. Make sure to start with the fraction when you are adding your mixed numbers. Okay, so now for our second example, which is subtraction. 12 and 1/2 minus 5 and 1/3. And again, it's easiest to write it vertically while lining up your whole numbers and your fractions. And even though this is a subtraction question, I am going to be using least common multiple again. So to the side, I'm going to write both my denominators, my 2 and my 3, and I'm going to list the first 5 multiples of each number, including the number itself. So for 2, I have 2, 4, 6, 8, and 10. And for 3, I have 3, 6, 9, 12, and 15. I again find the least common multiple, which is the smallest number that appears on both lists, which is 6. So that means I'm going to convert my 1/2 and my 1/3 into sixths. And then I'm going to subtract using sixths. Make sure to multiply the numerator times the same number you used to get 6 in your denominator. So my 1/2 becomes 3/6 and my 1/3 becomes 2/6. And then I go ahead and subtract, beginning with my fraction. 3/6 minus 2/6 and 12 minus 5 equals 7 and 1/6. That completes our lesson for today. Please let me know if you need any more help. And thanks for watching.